we are going to start by talking a little bit about interpreting box and whisker plots. Now, in these box and whisker plots that I have given you here, there is no number line below them. Now, most of the time, we should see box and whisker plots with number lines below them, because the number lines give us some sense of where are these box and whiskers, like what do they mean? But sometimes we do see actual numbers written on these box and whisker plots. So maybe like that is 18, that is 21, that is 45, that is 62, and maybe that is 75. If you see a box and whisker like this, what that is telling you is the minimum is 18, Q1 is 21, Q2, or the median, is 45, Q3 is 62, the upper quartile, and then the max value is 75. But most of the time, they will normally give you kind of a number line below, and you will have to read off what are the values for that. Okay, now, when it comes to interpretation, the box and whisker actually does mean something. So the lower 50% of the data is down here, and the upper 50% of the data is up here. And so that's something else that's important to think about, is with a box and whisker, the data has been arranged from smallest to biggest already. That's why we know that this is the median. Now, if we look at figure B, we notice that the bottom 50%, let me keep the same color, the bottom 50% of data is there, and the top 50% of data is in that space. And then for the last one here, we notice the bottom 50% of the data is in that interval, and the top 50% of data is in that thing. I would love somebody to come online and just tell me what are the differences that you notice between figure A, figure B, and figure C. I'll get rid of my little extra lines there. What do you notice when you talk? This is called a distribution or data distribution. What do you notice about the differences between these data sets? I would love to hear from everyone. Let's just have a check. Somebody said they can't see anything. Okay, let me, can you see, Callum? Hi, Callum. Okay, you can see. Okay, let me just re-share. I think some people are not seeing the screen properly. So let's just do a quick little check. Share the screen, and let's just see if everybody can see the screen now. So give me a happy face if you can see the screen now, or a thumbs up, one of the two. And give me an unhappy face or thumbs down if you can't see it. Okay, awesome. It looks like we're good. Okay, now that we're looking at these pictures, Pafunzo has said in B it's skewed to the right, and in C it's skewed to the left. Okay, so let me explain what the skewing thing means. It sounds like we're dealing with sausages or something. So if we look at this data set to start with, it looks like the bottom 50% of the data and the top 50% of the data are roughly the same. And we say that the data set is symmetrical because, roughly speaking, in fact, you can even look at the bottom 25% there and the top 25% there. They're about the same. So we say this data set is symmetrical for A. Now, when we look at B, the top 50% is way more spread out than the bottom 50%. And so when that happens, think about going to the right. If you go to the right, it's positive. We say that this data set is positively skewed. Or we can say it's skewed to the right, like it's more spread out to the right. You'll also notice that the top 25% is more spread out than the bottom 25%. So that further reinforces it's more spread out to the right, it's positively skewed, the data set. And then if we look at the bottom, we'll notice that the bottom 25% fits into that range of numbers, and the top 25% is squeezed here. And you see the same thing happening with the bottom 50% and the top. So we say that this data set is negatively skewed or skewed to the left. You kind of imagine the number line going negative to the left. And this is just a way that we summarize the data set. So when we talk about a data set, we can say it's symmetrical if it's roughly spread out the same. If it's more spread out to the right, it's positively skewed. If it's more spread out to the left, it's negatively skewed. And this question is asked when we have to summarize things in box and whisker plots. And I see in the chat here, Naledi, Callan, Pufunzo have all made useful comments. Okay. I want you, this is a box and whisker plot with there's three box and whisker plots. One is for form A, one is for form B, one is for form C. And each of these films will have a collection of people or a set of people who are reviewing them, right? There's a whole bunch of reviewers for form A, a whole bunch of reviewers for form B, and a whole bunch of reviewers for form C. And what they're summarizing here is they're summarizing the ages of the people who are reviewing the films. I want you to comment in the chat on what is the distribution of age, because it's about the age, of the reviewers for film A. What is the distribution for film B? And what is the distribution, or comment on the distribution for form C? Can you please do that in the chat for me based on what I was just saying about skewness? Or if you'd like, you can pop your hand up if you would prefer that. That's also fine, up to you. So we're commenting on the skewness of the data set. Okay, Pufunzo, let's go to you. What comment? Just give us one of the these answers. Which one would you like to answer on?
Hi, sir.
Hi. Which
Okay,
one would you
so
like to
on film B,
Okay, tell me what you think about film B.
it's negatively skewed.
Okay, let's have a look. So negatively skewed. Who comments in the chat? Thank you very much, Pufunzo. Does anybody agree or disagree with Pufunzo? Let's have a look in the
No,
chat.
sir, it's positively skewed
Oh,
because
positively
to
skewed.
the right.
Yes, now I agree with you, because you can see it's more spread out to the right. So don't be attracted to this little bit. Remember, we're looking at the ones that are more spread out for skewness. They both start with an S. So this is positively skewed or skewed to the right. Thank you, Pufunzo. Who would like to comment on another one? Who has something that they Simcom Sisipo has said B is positively. I agree. Naledi has said B and C are positively. Well, let me have a look. So if I see the top 50% of the data, it goes there. The bottom 50% goes there. To me, film A looks, this is longer than this part. So I would say film A is negatively skewed or skewed to the left. The data set is skewed to the left or negatively skewed. And I always like to put these little squiggles to help me. What about Naledi? I'll see if I can leave and come back in a second in case to fix the screen problem. What about film C? What do we find with film C? Is that positively or negatively skewed? Well, I don't know if it's symmetrical. I mean, it's definitely better. It's symmetrical out here. Like if we go, the top 25% and the bottom 25% of the data are about the same. They have the same range. But if I look at the squiggles on top, the top 50% is way more spread out than the one below. And so I would say that this is positive. Oh, I'm spelling all funny. I'm just going to say positively skewed. I'm just going to reset my screen again because I think the lady said there was some issues. So let's try. I'll just be back in a second. Okay, so we're getting there. I want you guys and girls to write down for me the 5-number summary for this data set, and I want you to tell me, comment on the data distribution. So you have to tell me what is min, max, Q1, Q2, Q3, and you have to comment on the distribution of this data set. And this is a summary of the data of scores from a test in a class. So what this graph is summarizing is it's summarizing all the scores together for the students in a class. There's a whole bunch of students who have taken a test, and this is summarizing their data. So where is the min value? It's all the way down here. So the minimum value is 21. So that's Q1 is 27. Q2 is 31. Q3 is 33. And the max is 34. How else can we comment on this data? What is the data distribution? What can we use to summarize the distribution of data? I'll give you a hint by drawing in some squiggles. So remember, that's the median is there. And there's that one. How would we describe this data set? So Sipho has put something in, Buchle has put something in, Profunzo has put something in there. Indeed, it looks like this data set is more spread out to the left. So we can say it is skewed to the left, or we can say it is negatively skewed. Okay, for bonus points, an interpretation question. Between which two values does the middle 50% of data lie? Between which two values does the middle 50% of the data lie? So you need two values. Between which two values does the middle 50% of the data lie? Who feels like they know which two values are involved in the middle 50% of the data? Well, the middle 50% of the data is the region inside the box. And the box has Q1 on the one side and Q3 on the other side. So do we know what Q1 was? It was 27. And what was Q3? It was 33. So the middle 50% of data is sitting, so half the data, the middle 50% is sitting between, basically 50% of the class got between 27 and 33 for their result for the test. All right, now I want to know, what is the interquartile range? What is the interquartile range for this data set? What is the interquartile range for this data set? Can anyone remember how we work out the interquartile range? It's Q3 minus Q1. So it's the big one here minus the small one here, which is going to be 6. The interquartile range is 6. Okay, give me a score out of 10 for how you are feeling about the content we've covered so far. Give me a score out of 10 for how you're feeling. 0 is no understanding, 10 is perfect, 5 is okay, but needs to improve. How are you feeling about the content so far? Thank you, everyone, for voting. It's very, very helpful. Okay, let's just do this question, and then we're going to move on to group data. So this is an old exam question. Step 1, I want you to look at this. They tell you the 5-number summary here, and I want to know what is the interquartile range for these tree heights. Step 1, determine the interquartile range. Naledi, we have done a whole unit on functions. What I would suggest is to look at the recordings that we've done on functions, Naledi. So I'm just going to put our YouTube channel is where we have put all the past recordings. And so if you would like to look up those things, you can have a look. In fact, I'll even send you the link to the playlist on functions in the chat in a moment. Oh, sorry, it's Sinako, not okay. Yeah, there we go. I just put that link there. Okay, what is the interquartile range? Well, for this question, the interquartile range would be Q3. So what's Q3? It's 53 minus, what is the Q1? It's 42. So it is going to be 11. So basically, that is the interquartile range. Okay, next question. What percentage of plants has a height they meant in excess of 53 centimeters? So they're saying, what percentage of plants is taller than 53? So what they're saying is what percentage of plants falls into this region over here? Because 53 is straight down there. So how much of the data sits between Q3 and the max value? I'd like you to try and put that in the chat. Who thinks they know how much of the data will sit after Q3? Because remember, the edge of the box is Q3. That's Q3. That's Q1. That's Q2. That's the minimum value. That's the maximum value. Okay, it's not 22. It's 25%. So 25% of the data will sit between here. Because remember, Q3 is the 75th percentile. So we know 25% of the data sits over there. Another 25% fits between Q2 and Q3. Let me use a different color. Then another 25% sits over here. And then the lowest 25% sits over here. So between the minimum and the first quartile, there's 25%, 25%, 25%. And then since we only want those trees above 53 centimeters, this region here is what percentage has a height above or in excess? It's going to be 25% of the plants. All right. So because you don't have to calculate them, it's because a quarter of the data sits after the third quartile. Between the quartiles is always a quarter of the data, if that makes sense. There's no calculation. All right, one more question. Then it says, between which quartiles do the heights of the trees have the least variation? So between which quartiles? So is it between here and here that there's the least variation? Is it between here and here? Is it between here and here? Or is it between here and here? What do we think? Between which two quartiles do the heights of the trees have the least variation? So which 25% looks the narrowest? I think that this bit here looks the narrowest. Like, look at how 25% of the data fits between here and 25% fits here. But look how small the blue bit is. So we say there's the least variation. They're the most together between Q2 and Q3. Because you can see how narrow. That's why there's the least variation. If they were more spread out, they'd be more varied. But because they're so close together, they have the least variation. Now, I might have lost a couple of you there. Does anybody have a question or comment about that one? So if the data is squeezed into a smaller area, we say that it has less variation. If it's very spread out, if the data sits in a more spread out region, we say it has more variation. Okay, the questioner said, what percentage of plants have, people don't understand how B works. So all I want to say for B is, can you find 53 on this number line? Can everyone see that 53 is over here? Now, what is important about the end of the box here? Q3 is in line with this. Now, the Q3 or quartile 3 or the upper quartile, it divides the lower 75% of the data sits here, and the last 25% of the data sits here. That's why it's called Q3. So 75% is below, 25% is above. When they say what percentage of plants has a height above 53, they're saying how much of the data is sitting here. And we know that 25% of the data sits there. So what I'm going to say is, if you don't understand this example, that's fine. It was a bit tricky. What you can do is you can re-watch this recording, and there's a little quiz question about this that will give you some extra practice on that. Okay, so I don't want you to worry, but we are going to move on now. But you can re-watch this bit on the recording just to get a little bit extra understanding. Okay, before we move to our break time, what I'm going to do is I'm going to say, let's introduce this question. It says here, a list of areas in kilometers of the islands in the world is given below. And what they have on the left-hand side are different islands. So I'm sure many of you have heard of Madagascar, which is an island off the African coast. There's also somewhere called Greenland, and then there's also somewhere called Sumatra, which is in the east, and so on. Which island has the biggest area if you look at the table? Which area has the biggest, which island has the biggest area if you look at the table? I want you to tell me in the chat. So I can definitely see that Greenland is the island with the biggest landmass. Which one is the smallest? Which island has the smallest landmass? Which island? Okay, the island with the smallest landmass is this. Now, what's different about this example is it says, if intervals of 250,000 kilometers squared are used, into which interval will most of the islands fall? Now, this is a case of, this is a list of data and its area. But what this question is implying is it's saying, look, we need grouped data where we put the data into intervals. And so what I'm going to do now is I'm going to make a grouped data table. Okay, so this is a grouped data table. And it says we start, well, we'll start from 0. Okay, I'm going to go from 0 to 250. Then I'm going to go from 250 to 500. Now this is thousands, so I'm adding thousands to my column. This is 500 to 750. This is 750 to 1,000. This is 1,000 to 1,250. This is 1,250 to 1,500. And then I'm going to carry on below. I'm just doing a little squiggly one just to show you. Okay, so in my grouped data table, what I'm going to say is area in kilometers squared. Then I'm going to have a tally. Then I'm going to have a, excuse the bad handwriting, but I just want to do this quickly here. Then I'm going to have frequency. And then what I might even add is something called the midpoint. In fact, we're going to take a break, and I'll come back to this after our break. But give me a thumbs up if you followed what I've done so far. Give me a thumbs down if you have no idea what I'm doing in terms of organizing my data now. Because the data, I want to go from a list into a grouped data table. Okay, we need to take a break, otherwise our brains are going to shout at us. So let's just all stand up for a second. Let us get away from our tables or our chairs. And all we're going to do is take 3 deep breaths to get some oxygen in our body. So one more breath. And then I want you to shake your arms around just to loosen up. Shake your legs. And then we're going to do 15 jumping jacks. This is what a jumping jack is. It gets your blood pumping. And we're going to go in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And just take one more deep breath. And then I want you to sit back down. Okay, and then I want you to hit your favorite emoticon from the list below. What emoticon do you like the most? I'm going to choose the one that I like, if I can find it. Where do my emoticons go? I like the party emoticon. There we go. Fantastic. All right. So, and then let me know in the chat, do you feel like the little power break has made your attention get better? Does it make any difference? Let me know in the chat if you feel like our little exercise break helped your brain come back a bit. Or do you feel like it doesn't really make, for me, it makes such a difference. I feel like, boom, my concentration is reset. Okay, so back to this. What is grouped data? If I go through this for the tally, I'm going to cross off the first one. Oh, Bukle, let's go to you. I see you've raised your hand. Do you have a question?
Sorry, I can't see your screen.
Oh, okay. Let me reset the thing just so that we have. I don't know why my thing is being so difficult today. So I'm just going to reset my screen. Give me a thumbs up if you can see the screen. Give me a thumbs up if you see the screen. Okay, fantastic. Just let me know if you have any issues. I thought so, Omakhalan. I also agree. Adrenaline is good. All right, let's do our tally chart. So Greenland would go in. Oh, wait, I need another category for my table. Okay, so I need another category for my table. I need 2,000 to 2,250. Oh, this is horrendous, but you get the basic idea of what I'm trying to do. So one tally there, 7,899 would be over there. 751 would be there. 587 would be there. 507 would be there. 422 would be there. 230 would be there. 229 would be there. 217 would be there. 196 would be there. 178 would be there. Okay, now what we can do is by looking at the tally column, we can get our frequency column, which is 2, 4, 2, 2, and 1. So all these categories kind of in the middle don't really matter. The midpoint of my interval would be 125, and then it would be 375, then it would be then it would be 625, then it would be 875, and then it would be 1125. I'll leave that one out. 1625. This would be 1875, and this would be 2125. Okay. Let me look. There's some questions in the chat. Oh, so won't 217. 217, where did I put it? I put 217. Won't 217? Oh, you are quite right. 217 and 229. I've made, let me do this again. I've made a bit of a blups here. So let's go back and do it again just in case. So we are happy with that one. 789 would be there. 751. 587 would be there. 507 would be there. 422 would be there. 230, ooh, would be there. 229 would be there. 217 would be there. 196 would be there. Oh my goodness. So I actually get 51221. Give me a thumbs up if you feel like you agree with me now. Give me a thumbs down if you think I've made another error. Okay. All right. After all that work by Mr. Skitter, let's try and answer this question. So it says, which interval will most of the islands fall? A, B, C, D, or E? Which one do you think most of the islands are going to fall into? Okay, let's go to Bukle. Hopefully I can unmute Bukle. Bukle, which interval do you think has most islands?
So I think it will be A, but I have one question.
Okay, go ahead.
For the intervals, in the previous lesson, the intervals, we didn't use the same number for each interval. Like for instance, I'm seeing the first one is 0 to 250. Why are we using 250 again to 500? Shouldn't it be like 251 or something? I'm not sure.
Okay, so I'm going to go into that in future lessons. So you're right. So Bukle, what you've done is you're talking about the endpoints. So just because I was in a rush, I kind of simplified it, but you're correct. Does everybody get what Bukle means? Like 250 should end here, and then this should start with 251. I'm going to go into that more in the next lesson, but I just want everyone to be aware there should be no overlap. But because none of the points fell exactly on the edge, it won't be a problem. Does that make sense, Bukle? So for now,
Yes,
it won't be an issue. Yeah. Cool. Okay, I agree. The answer is A. So now we call this the modal interval. Why do you think we call it the modal interval? Who has any ideas why we would call this for grouped data? We don't have a mode, we have a modal interval. Who feels like they would understand that? Funzo, let's go to you. What do you think?
Okay, so I think maybe it's because of that it is the number, it is the highest number.
Yes, perfect. So you know, like the mode is the one that occurs the most often. The
Mm.
modal interval is just the interval that occurs the most often or has the most values. So for group data, we don't have a mode, we have a modal interval. Perfect. Thank you. Okay, now, if we have a modal interval, then shouldn't we also have a median interval? Okay, well, I want to know, in previous lessons, when we looked for the median, we had to use the position formula, a half times n plus 1. Okay, now what is n going to be in this particular data table? So in this example, where we're counting up islands, what is n going to be equal to? So 5 plus 1 plus 2, there's going to be 11. Yep, 11. Perfect. Now, I've just thought, if I want to work out the position of the median, then I should use this formula. A half times 11 plus 1. So the position of the median is going to be in the 6th position, or the item in the 6th position. But we can't count like we could with a list of numbers. You know, like before, we would have a list and we'd count them. So how do we keep track of where the 6th island going from the bottom to the top is? We use something called cumulative frequency. So cumulative frequency, and I'm going to call it CF, is when we count from the bottom how much stuff has occurred and we keep track. So the cumulative frequency from 0 to 250 is 5. The cumulative frequency from 0 to 500 is 6. What do you think the next number is going to be that I'm going to write down in the cumulative frequency column? So from 0 to 500, I have 6 items. How many am I going to have if I go from 0 to 750? It's going to be 8. Yes, because I just count, there's 2 in this column. Then up to 1,000, we are going to have 10. And then up to the end, I'm going to have 11. Okay, which makes a lot of sense because we have 11 items in total. So what the cumulative frequency column helps us do is understand how many islands have happened up to this point. Okay, now I want to know, what is my median interval? I don't have a median like I do with list data. I'm now working with group data. What is my median interval going to be? Is it going to be A, B, C, D, or E? Which interval do we think is the median? Let's have a look at the chat there. Is anybody feeling brave? Which one do they think? Didn't we say that it was in the 6th position? So if I count, I think that this is going to be, if we count from the beginning, what's 5? There's 5 in this interval, and then there's 6. Or we can look here and say, up to this point, we've had 6. So I think the median interval is just going to be this one over here. And so that is going to be the interval 250,000 to 500,000. Or if we look at our choices here, it's going to be B. And so we'll say that that is the median interval. Let's go to Pabalelo, who has got a question. I think I might be. Let's go to Pabalelo. Pabalelo, how can I help? Can you hear me? I don't know if it's a bit quiet. Does anybody else have a question about how that would work? Give me a thumbs up if you understand how I found the median interval. Okay, so we have a median interval, we have a modal interval. What else could we actually work out? The last one that we need to be able to work out with data or with group data is something called the approximate mean. the approximate mean, and we can't get an exact mean value because the items fall within a range, but I need to show you how to calculate an approximate mean. But I'm not going to do it on this example because it's a little bit cluttered. So what I'm going to do is I'm going to move on to the next question, and then I'm going to help you figure it out from here. Okay, let me go back to, while I answer Pabelelo's question, I want you to look at this example and tell me which interval is the modal interval. And let me go to, hi, Pabelelo, can you hear me?
Hi, sir. I wanted to ask from the previous question, if our median was 10, were we still going to add 1?
Okay, if the median was 10, or if the n was 10, you mean? If n was 10,
Yes, sir.
you would still add 1 and then divide by 2 or times by a half, yes.
Oh, okay. Thank
Perfect. Okay, so over here, this is a bunch of, this is a choir teacher who kept a record of the number of learners who attended the 40 choir practices. So one person came to between 0 and 10 practices, 14 people came to between 40 and 50, and I want to know what is the most, what is the modal interval? What is the modal interval? So the modal interval, I'm just looking for the one that has the most people in it. And so my modal interval is going to be between 40 and 50 learners. Now notice here how we have the crocodile mouth. So the lowest number that occurs in this interval is 41 because it's greater than 40, and the biggest number that can occur is 50. This is what Buchle was talking about earlier in the lesson, about being exact about what's going on here. Okay, now let me go to the next question. So in this next one, it says we need to find the median number of learners at choir practice. Now, in order to find the median, I'm going to say that we need an extra column. I'm not sure all of you need this, but let's just try and do it. So I'm going to give you, oh, my hand, this is a bit squiff, but whatever. I'm going to give you the first 2 columns in the cumulative frequency column. What is going to go in the next space? So up to 20, we've had 3 people. Up to 30, what will be the next value in my cumulative frequency table? Provunzo, Callan, I see they've locked in answers. Who else wants to lock in an answer? Yeah, indeed, it's going to be 14. And then after that, it's going to be 23. And then it's going to be 37. And then it's going to be 40. And oh my goodness, this is such good news. The total is 40, just like it should be over here. All right, now we need to find the median interval. But in order to find the median interval, we first need to find the position of the median. So I want you guys and girls to find me the position of the median, and then we will work out what the median interval is for this data set. What is n? What is the position that we're looking for? So I go 1/2 times 40 plus 1, which is going to give me 20.5, or the 20.5th position. Now, I want to know in what interval does the 20 or 21st item occur. I want you to look and keep track. Up to that point you have 1, up to that point you have 3. What interval do you think will be the median interval. And I want you to use your thinking knowledge here. So which interval will this fall in? So I'm going to suggest the following. We haven't got there yet. I've got 3 items in total. I haven't got at 14 because I need to get all the way to 21. Oh my goodness, I've gone too far. I've got all the way up to 23. So you know what? It means that the position, or the 20.5th position, must be in this interval, because it wasn't in this one. I hadn't gone far enough. Now I've gone too far when I got to 23. So the median interval is going to be between 30 and 40. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow that, finding the median interval. So what I'm doing now is I'm finding the median for grouped data. I'm not finding the data. I'm not finding it for list data. I'm finding it for group data. All right. Now, I've run out of time today to do what's called the estimated mean. The estimated mean would be basically taking this group data and working out the mean. And the bottom would be divided by 40, but the top would have to come from this table. And what I'm going to do for that is I'm going to put a video on Google Classroom for you to look at to help you. Or what I will do is in the next lesson, I will carry on with this. But I just think there is a question in your quiz this week to do with estimated mean. And so that's why for some of you, if you just watch this video, in fact, the video you need to watch is just here. So I'm going to take this video and I'm going to put it on to Classroom right now. And I want you to watch that before you do the quiz. But to end tonight, I want to share the link to the quiz with you so that you all have access. But I think we've done more than enough for today. And so as we end today, I just want you to check that you can get into the quiz. So I'm going to put the link to the quiz below. And then what I'm going to do is I'm also going to put the link to the video I want you to watch. So let me do that. I'm going to put, and I want you to give me a smiley face once you see that you can access both the quiz for the week and the video that will tell you how to find the estimated mean. Yeah. All right, everyone.